Alright guys, so the next thing that we're going to be looking at is the idea of a central angle. So a central angle is located at the center of a circle. Basically it's formed when you connect 2 points that lie on the circle with the center of the circle. Right? So you get these two line segments and that creates an angle in the center here called a central angle. Now, in this lesson we're going to learn how the measurement of this central angle relates to the measurement of the arc. Now, it's important to note that there's two different ways that we can measure the value for an arc. The first way is that we can measure it with degrees, okay? So we know that the total number of degrees around a circle is 360. So how many degrees around the circle are we going out of 360? So what we learned in this first lesson is that basically the measure of the central angle will be equal to the measurement of the arc in degrees. Okay, so the arc that it spans would in this case be arc AC. So we would say that the measure of arc AC is equal to 84 degrees. Okay. So a little bit of notes now. So a central angle is an angle with its vertex at the center of a circle and its two sides are radii. Okay, both of these parts of the angle that form up the angle are radiuses. The sum of all central angles in a circle is 360 degrees. So an example of a central angle in this case would be angle ABC. Okay, and the degree of the arc formed by the endpoints is equal to the degree of the central angle. So the measure of arc AC is equal to 84 degrees, and the measure of arc ADC, in this case, ADC, that's the major arc, would be basically 360 minus 84. So in this case, what would that equal? You need 16 plus 60, and then 200 more. So 276, right? Okay, so let's get into some examples here. First example. So we're asked to find a bunch of different arcs. So what we notice is that N is the center of the circle. So that means that this angle would be a central angle, and therefore this arc would have the same degree measurement as that central angle. Now, using the idea of vertical angles, we could assume this would also be 21, and therefore this arc would also be 21. So now that we have that information, we can also realize the fact that there's 360 degrees in the entire circle, right? Now we've already accounted for 21 and 21, which is adding up to 42. So if we subtract away 42, we're left with 318 degrees now to be divided by these two remaining arcs. So if I divide this by 2, I'll have 150 and 9, I think. 159 for each of these two arcs. 159 here and 159 here. Okay, so now we've figured out all of the 4 different arcs, and we can begin to fill in some of these values. So arc JK is going from J to K. That is 21 degrees. The measure of angle JNM. JNM, where is that? Let's see, JNM. So that's actually this angle here. So notice that this angle is going to be equal to the arc that it spans across, okay, that it opens up to. So the angle and arc are going to be the same measurement of 159 degrees. Now KL is spanning this way, over here. So that's 159 degrees. Okay, so let's fill that in. 159 degrees for KL. Now we have JKM. So JKM, from J to K, are all the way around to M. So we're crossing 21 and 159 and 21. So if we add those together, let's see, 21, 159, and 21. So that's already 42 and 159. Okay, so we add this, we get 201, right? Next we have arc MKL. So let me just remove this one. arc MKL. So we start at M, we start going towards K, which we're not really sure which way to go until we realize that L is the last letter. So notice that if I tried to go toward the right from M, I'd go to M, then I'd go to K, and then to get to L, I have to wrap around all the way like a full circle and then some. So I know that's not correct. So an arc should never be more than a full circle. So I know the correct direction would be to go this way, MKL. Okay? So notice that this spans all the way around the circle except for this 21-degree section. So that means it's really going to be 360 subtract the 21 degrees that it doesn't hit. So that's going to be 339 for that arc. Okay? Let's move on to the next one. Right, so the next one here, right away, we can see that this is 90 degrees due to that box. And so this arc would also be 90 degrees between those values. We can also see that this one would have to also be 90 degrees, right? And if you're not sure of that, just notice that this is a straight line. And we know that a straight line has 180 degrees, 90 of which are already taken up by the other angle. So again, we can say that this arc would be 90. And since this arc is 34, we could say this angle would be 34. Okay. And same reasoning that I said over here could also be applied to ensure that this is a 90-degree angle, right? So we have 90 here, and we have 90 for this arc. And now what I can do from here is I can realize that this corner would also have to be 90, but 34 of that is already taken up. So what's left is just 56, and that could go here. Okay. All right. So now we can already start filling in these values here. So arc CD is 90 degrees. Arc FD, where's arc FD? So arc from F to D, I would have to go this way, because if I tried to go the other way, that would be a major arc. And a major arc would require 3 letters. So you can tell these ones are the major arcs. Minor arcs have only 2 letters. Okay. So I know to go this way from F to D, and I notice that it's a 34 degree plus a 90 degree. So if I add those up, I should get 124 for arc FD. Next we have arc DCF. So for arc DCF, I would start at D, go towards C, and then go all the way around towards F. And notice that this is a major arc, so it's supposed to be more than 180 degrees, which it is. So now I can simply add 90, another 90, and 56. So that would be 180, whoops. So that would be 180 plus 56. So that would be 236. 236, okay. Next is GDF. So if I remove that, from G, I go to D and then to F. So notice I'm going to have to go around this way, right? So G to D to F. Notice it's the entire circle except for 56 degrees. So I would do 360 minus 56 degrees. Whoops. 360 minus 56. And if you do the math there, you should get 204 degrees. Right. Okay, so now it's your turn, guys, to try numbers 2 and 4. I'll pause while you work on those. All right, so hopefully you've had a chance to try numbers 2 and 4. So now let's check them out together. So first thing, we have 87 over here. So this arc would be 87, okay? Let's see what else we could figure out. We know that this arc here is 72, so that means this angle would have to be 72. And then by vertical angles, remember anytime you have an X, angles across from one another are equal. So I could also say that this would be 72 degrees angle by vertical angles. And therefore this arc, which spans that angle, would be 72 degrees. So from here, I can do a few things, but my first move would be the following. This line is representing a diameter of the circle, which means that here I have to have 180 degrees. So far I only have accounted for 72 degrees. So that leaves 108 for the left-hand side over here. And since that angle is 108, the arc would also be 108. Okay. And I can do the same trick on the other side of that green line. So here I have 87, 72 so far. So that combines to 159. Take that away from 180, and I'm left with 21 degrees for that sliver over there, okay? And also for that arc. So now let's start filling in the information they wanted to know. So angle UXV, let's see if we could trace that out. Starting with U, we go to X, which is the center, and then V. So that angle is 72 degrees. So let's fill that in, 72, okay. Next information is arc ST, so that's the arc that spans across ST, that's 21. Arc WV, so it's a minor arc, WV is 108. Arc TW, so from T to W, okay, notice it's 21 plus 72. 21 and 72 makes 93. Next, TVW, so this time it's a major arc, so we're going the long way around the circle, from T to V, then to W. So we can add 87, 72, and 108. So let's try 87, 72, and 108. So 8 and 2, 10, 17, 16, and 2, 267. Okay, next one. So here we have a 19-degree arc. So this arc, 19-degree angle. So the arc outside of it is also 19. Vertical angles gets me that this is 19. This arc would also be 19. Okay. Notice here that I have a 90-degree angle. So I could do 90 subtract 19. Okay, and that leaves, I believe, is it 71? Yeah. So 71 degrees can go there, and also can go for the arc outside. Next, I realize that this has to also be 90 degrees, since this piece here is a diameter. Remember, a diameter has to equal 180. 90 is already accounted for on the right side, so 90 must also be appearing on the left side. And this would have to then be 90 degrees due to the central angle idea. And finally, since that's 19, this would also have to be 180. So 180 subtract 19, 161. So that would go over here, 161. Also for the arc, it would be 161. So let's fill in the information. PQ, arc PQ is 71. Okay. Arc SR, SR is 161, right? Measure of arc QRT, from Q to R and all the way to T. So here's a little shortcut, guys. If you notice, just from R to T by itself is 180 degrees. So then you could simply add 19 onto 180. So 180 plus an extra 19 would be almost 200, not quite, 199. So we could fill that in there. Okay. All right. Next, we need to do PSR. So let's start at P. We go to S and then to R. So we're wrapping around everywhere except for this 90 degrees section, right? So we're doing a full circle except for 90 degrees. So to find it, we could do 360 subtract 90, and that equals to 270. And again, there's more than one way to find these sometimes, but usually there's some ways that are more efficient than others. Measure of arc PS, so from P to S. So that would be 90 and an extra 19. So that's looking like 109. Okay. Very good.